In this session, the content covered would be probability and probability distributions, statistical inference, correlation and regression analysis using R. In previous session, we have seen how to enter the data to R and compute simple statistics using R. Now, in this session, we will see how we can use R codes to compute probability and probability distributions and for some inferential statistics. Next, we will see probability distributions and simulation. We look at some of the basic operations associated with probability distributions. There are a large number of probability distributions available, but we only look at a few. If you would like to know what distributions are available, you can do a search using the command help.search open the bracket distribution close the bracket. To get a full list of the distributions available in R, you can use the following command help distributions. R allows for the calculation of probabilities including cumulative, the evaluation of density and mass functions, and the generation of pseudo-random variables following a number of common distributions. We will specify the distribution, the R name in that distribution and the additional arguments. The distribution beta, the R name is beta and additional arguments would be shape 1 alpha, shape 2 beta. Binomial binom, size n and probability p. Chi-square CHISQ, degree of freedom. Continuous uniform distribution UNIF, minimum theta 1, maximum theta 2. Exponential EXP, rate within brackets 1 by beta. F distribution, a small letter f, df1, df2. Gamma distribution GAMMA, shape open the bracket alpha, scale beta. Hypergeometric HYPER, m is equal to r, n is equal to n minus r, k is equal to n. Normal NORM, mean mu and standard deviation sigma. Poisson POIS, lambda. T distribution T and degree of freedom. Weibull WEIBUL, shape and scale has to be specified. Prefix each R name given above with D for the density or mass function, P for the CDF and Q for the percentile function and R for the generation of pseudo-random variables. We will see some examples. X assignment operator R norm 100. It simulates 100 standard normal random variables put in X. W assignment operator R EXP open the bracket 1000, rate is equal to 0.1. It will simulate 1000 from exponential theta is equal to 10. D binom open the bracket 3, size is equal to 10, PROB is equal to 0.25. It will compute probability of x is equal to 3 for x following binomial distribution n is equal to 10 and p is equal to 0.25. P binom open the bracket 3, size is equal to 10, PROB is equal to 0.25, close the bracket. This will compute probability of x less than or equal to 3 in the above distribution. P norm open the bracket 12, mean is equal to 10, standard deviation is equal to 2, close the bracket. This will compute probability of x less than or equal to 12 for x following normal distribution with mu is equal to 10 and sigma is equal to 2. Q norm open the bracket 0.75, comma mean is equal to 10, comma standard deviation is equal to 2, close the bracket. This will compute third quartile of normal distribution, mu is equal to 10 and sigma is equal to 2. QCHISQ, open the bracket 0.10, degree of freedom is equal to 8. This will compute 10th percentile of chi-square distribution with degree of freedom 8. QT, open the bracket 0.95, comma degree of freedom is equal to 20. This will compute 95th percentile of T20. Next we will see statistical inference, how a independent sample t-test can be carried out. The format in which data has to be entered is, first column will have the values of first variable, that is x, second column will have the values of second variable, that is y, where x is quantitative and y is also quantitative. Read the data. Data, assignment operator, read dot table, and within brackets e colon backslash r data dot txt, comma header is equal to true. Data, it will display the data. Then we will access the data, x assignment operator data $x semicolon, y assignment operator data $y semicolon. Next we will test for normality of the data. For this Shapiro test is used. So the command is shapiro dot test of x variable and shapiro dot test of y variable. If any one of the variable is significant, then proceed to step 7. Next we will test for randomness. For this, first install the package rand tests, then library rand tests, runs.test of x, runs.test of y. If any one of the variable is significant, then again proceed to step 7. So the fourth step is test for equality of variances. var.test, open the bracket x comma y comma ratio is equal to 1 comma alternative is equal to 2 dot sided semicolon. If the test is significant, then proceed to step 6. Next is step 5. Independent sample t-test is carried out for equal variance. Two-sided alternative. The command is t dot test, open the bracket x comma y comma alternative is equal to within double quotes 2 dot sided comma variance var dot equal is equal to true, close the bracket semicolon. Then if it is alternative mean of x greater than mean of y, then the command is t dot test, open the bracket x comma y comma alternative is equal to within quotes greater comma var dot equal is equal to true, close the bracket semicolon. If the alternative is mean of x less than mean of y, then the command is t dot test, open the bracket x comma y comma alternative is equal to within double quotes less comma var dot equal is equal to true, close the bracket semicolon. Then we see the command independent sample t-test for unequal variance. So for two-sided alternative, the command is t dot test, open the bracket x comma y comma alternative is equal to within double quotes 2 dot sided comma var dot equal is equal to false, close the bracket semicolon. If alternative mean of x greater than mean of y, then t dot test, open the bracket x comma y comma alternative is equal to greater comma var dot equal is equal to false, close the bracket, semicolon. Alternative is mean of x less than mean of y, then the t-test command is t dot test, open the bracket, x comma y comma alternative within double quotes less comma var dot equal is equal to false, close the bracket, semicolon. If the parametric t-test fails, then the command for non-parametric t-test for independent sample t-test is Wilcoxon test. So, the command is for two-sided alternative Wilcox dot test, open the bracket, x comma y alternative is equal to 2 dot sided within double quotes. Then alternative mean of x greater than mean of y, the command is Wilcox dot test, open the bracket, x comma y comma alternative is equal to within double quotes greater than, close the bracket, semicolon. Alternative mean of x less than mean of y, then the command is Wilcox dot test, open the bracket, x comma y comma alternative is equal to within double quotes less, close the bracket, semicolon. Next we will see how we can do interval estimation. Interval estimation of the population mean can be computed from functions of the following R packages. So, stats contains the t dot test, teaching demo contains the z dot test, BSDA contains the z sum dot test and t sum dot test. We take an example. The data is the score of 33 random students from College of Science and Mathematics, 84, 93, 101, etc. The population of these scores are believed to be normally distributed with 6.8 standard deviation. Determine and interpret the 95% and 99% confidence interval of the population mean. So, we observe that the sample size is greater than 30 and hence we apply z-test. So, first we will read the data to the variable scores. Scores assignment operator C, open the bracket and read all the values, close the bracket. Then use library, open the bracket, BSDA z dot test, open the bracket, scores comma sigma dot x is equal to 6.8, close the bracket. The output is as shown below. Data, it specifies the data, that is scores. The z value is 76.3126 and p value is less than 2.2 e power minus 16 and the alternative hypothesis is true mean is not equal to 0. So, the 95% confidence interval is 88.01327 to 92.65340. Sample estimates. Mean of x is given to be 90.3333. So, we see that above 95% was taken as default. Now, for 99% confidence interval, the command is z dot test, open the bracket, scores comma sigma dot x is equal to 6.8 and conf dot level is equal to 0.99. So, one sample z test, it will give the output as data scores, z is equal to 76.3126, p value is less than 2.2 e power minus 16, alternative hypothesis is true mean is not equal to 0 and 99% confidence interval is 87.28425 to 93.38241. The sample estimates of mean of x is 90.3333. Next we will see correlation and regression. Correlation is the study of the relationship between two or more variables. Then R codes for correlation is COR, open the bracket, variable 1, comma, variable 2 and close the bracket. So the command to test correlation is COR dot test, open the bracket, variable 1, comma, variable 2. The command to do Spearman's rank correlation is COR, open the bracket, variable 1, comma, variable 2, comma, method is equal to within double quotes Spearman, close the bracket. Next we see how to do simple linear regression analysis. The objective is to describe the relationship between two variables, say x and y, as a straight line. That is, y is modeled as a linear function of x. So x is the explanatory variable and y is the response variable. Consider the following example. A random sample of service call records for a computer repair operation were examined and the length of each call, that is in minutes, and the number of components repaired or replaced were recorded. The data is as follows. So we see that we have 14 observations and we have the minutes and units recorded. Let x be the independent variable, that is units, and y be the dependent variable, that is minutes. The expected model for the data is y is equal to beta naught plus beta 1x. First, save the data in text format in E drive of your computer with the name as raw data. The R code is as follows. Data, use the assignment operator, read dot table, open the brackets, within quotes E colon backslash raw data dot txt, close the quote, comma, header is equal to true, close the bracket, semicolon. Then use the command attach, open the bracket, data, close the bracket, semicolon. Plot, open the bracket, units, comma, minutes, close the bracket. Fit the regression model using the function LM, open the bracket and close the bracket. Data 1, assignment operator, LM, open the brackets, minutes follows units, comma, data is equal to data, close the bracket. Use the function summary to get the results. So summary of data 1. To conclude, in this session we have seen how we can compute some simple probability and probability distributions using R and some inferential statistics such as t-test, Wilcoxon test, correlation and regression.